Lesson 5, Measuring the Variability for Symmetrical Distributions. There are two outcomes. One is borrowed from Lesson 4, calculate the deviation from the mean and explain its meaning. And then the second one, calculate the standard deviation for a set of data. That's going to be our main focus for this particular video. In example 1, we're going to start to model and describe how to calculate the standard deviation. So here's a dot plot of the lives from brand A batteries from lesson 4, where we had the batteries that had the life hours of 83, 94, 96, 106, 113, and then 114. So what we did to work out this standard deviation is follow these particular steps. First, find the deviation from the mean. And so what we did in this line here is we subtracted the mean, the average of these 6 numbers, from each one of these particular pieces. As noted from lesson 4, it's a minus if it was below the average, which these 3 are, and it's a plus, which means that it was above the average for each one. The second step for following the standard deviation is to then square the deviations from the mean. For example, when the deviation of the mean is negative 18, then the square of negative 18, or negative 18 squared, is 324. So that's this piece right here. Negative 7 squared will give us the 49. Negative 5 squared is 25. 5 squared is 25. 12 squared is 144. And 13 squared is 169. The most common mistake that students will make is they're going to go to their calculator and they're going to type, for example, negative 18 squared, and then they're going to say, well, my square deviation is negative 324. But it's important to realize that negative 18 times negative 18 is a positive, so they should be getting a positive 324. So if they are going to the calculator, they need to ensure that they are putting their parentheses around the negative 18 before they square it if they want to ensure the appropriate answers for this particular activity. The third step is to add all the squared deviations, and we can see that being outlined right here. We took this entire row right here, and we're just going to add all of that together as observed right here to get 736. This result is known as the sum of the squared deviations. Now we're going to take that number of values denoted by n. In this example we had 6 values, so where am I getting 6 is right here. 1, 2, 3, 4, 5, 6 values. And so we're going to take and do n minus 1, which is part of the step. So we have 6 minus 1, that's equal to 5. And we're going to take that square and we're going to divide that by 5 to get 147. The final step in this piece to find the standard deviation is to take the square root of 147.2, and so that gives us 12.13. And so that is the standard deviation. While it is complicated appearing at first, but it does get easier with a little bit of practice. The students will have numerous opportunities in class to practice this idea of standard deviation. And there's also some additional examples and exercises within the student's handbook to go through this piece. To sum up the standard deviation, we have the lesson summary, and it calculates at steps 1 through 6. And so again, we say number 1, find the mean of the data set. 2, calculate the deviations from the mean. 3, square the deviations. Number 4, add up all those deviations and then divide by n minus 1, where n is the number of values that you have, and then take the square root. These are the steps that in Algebra 1 that we're expecting the students to take. Later on in math, it may be discussed, or your algebra teacher may even illustrate this formula down here at the bottom is the official formula for standard deviation. The students are not expected to memorize, nor is this formula in particular discussed or described. It is just there for notation for the students. We're only expecting the students to take and carry steps 1 through 6 as a systematic process to calculate the standard deviation at this point in their learning.